Hey, hello, welcome to the show. It's me, John Park, and you are here in time for JP's product pick of the week. Hello, thanks for joining. Oh my gosh, is my audio peaking? We're going to have some audio fun today because this is an audio-based thing. I'll try not to yell so much, I got excited. I will be, first of all, checking to see, I think I've got an actual stereo output, or mono in both channels output of the audio here today. Last week's was in one channel only, which you may not notice unless you're wearing headphones and then your head wants to suck itself inside out. It's the worst. So that was last week. But now I think I've got it all straightened out, and I've got things set up to to demonstrate some actual stereo effects today. Why is that? Well, that's because I've got a new product pick that involves stereo. If you want to go and check it out before I even utter another word about it, then head to this URL right here. It's product ID 3678. You can go to that URL. You can go to that QR code. That'll take you there. And we will have this product pick on 50% off. So slashed in half the price is. We stashed a bunch of them before the show. And we are offering them just at that price. You don't need a coupon code or anything like that, so you can throw it in your cart, up to 10 of them, no resellers allowed. Throw them in your cart, you'll get them at the discounted price during the show. After the show, price goes back up. It's a bargain anyway, but if you are here, perhaps you like the super bargains. I suspect that to be the case. However, as is custom here on JP's Product Pick of the Week, before I say any more, I'm going to have Lady Ada jump back a little bit in time. We've got just a brief clip. This one actually discusses a search because she was looking to replace a part, but then there's a plot twist at the end, so check it out.
I had this really nice, low-cost I2S stereo output breakout called the UDA 1334. And what was nice about this is that it didn't require an M clock, which meant it worked great with a Raspberry Pi. It had stereo, line level out. It was very inexpensive. The chip was like $1. So that means I can, all the extra components you needed, and assembly and test and margins for distributors like DigiKey, have it be $7, which is a really good deal. So the only problem is that this got discontinued. NXP doesn't make it anymore, and they don't have a direct replacement. They did have the UDA for a while. You get the UDA 1334B. The B series did require an M clock signal. There's some amplifiers or I2S DACs that you can just do bit clock, data in, and word select. And between those three signals, it has all that it needs to generate the master clock or your system clock or whatever. And then it runs just fine. Some microcontrollers can generate an M clock signal, but like I said, a Raspberry Pi doesn't. Maybe the Pi 5 can, but the Pi 4 and earlier could not. And so that was an issue with people who wanted to connect I2S amps. So you can have a separate crystal, but now your cost is increasing in the complexity. It would be great to just have an amplifier that didn't require it. It doesn't require I2C as a driver, which is great because, not that it's anything wrong with the chips that do require drivers, but again, if you're using it with a microcontroller or with Zephyr or FreeRTOS, and you don't want to write a driver for the chip, you just want I2S to audio or audio to I2S. I'm a big fan of data goes in, audio comes out. Maybe there's a couple jumpers, but you're pretty happy with the defaults because you're not doing an audiophile project. So this chip got discontinued a couple years ago. Very sad, but I would like to replace it because it's a common request. We've had actually a couple people say, "Hey, have you come up with a replacement for this chip?" Back in stock. You're probably like, "Wow, I remember this. This is old school. UDA 1334A I2S DAC. I really like this DAC. Low cost, really good quality from NXP." Got discontinued, and then during the part shortage, the chips were like $10 a piece. And I was like, I don't want to stock something if I have to make it $30. But thankfully, the chip shortage is over. And the folks who are trying to charge $10 are now charging about 50 cents. And so even though I discontinued this, because I never thought I'd get chips again, I got chips again.
Yeah, that's right. She got chips again. And that's because, and that is why I should say, this is my product pick of the week because it's available again. My product pick of the week this week, it is the I2S Stereo Decoder Breakout. It is the UDA1334A, which we thought was gone forever, but now it's back. This is an I2S stereo decoder with a line level output over a TRS 3.5 millimeter jack. So you can just plug this into an amplifier or even some headphones and get on with your life. It allows you to stream some really nice high quality stereo digital audio data off of your microcontroller or single board computer. It takes care of all of the complex clock timings, and it gives you audio on the other side at a line level that you can use all over the place. So this I love. I love this kind of breakout. Really nice to see it back in stock. Let's first of all check out the product page for it. So that right there, you can see it is on discount today, right now, this next half hour or so only for $3.48 US, normally $6.95. I appreciate that not only did this come back in stock, but Lamore left the price alone. Even though this goes back a number of years, you can actually tell by the product ID. We're up in the, 6,000s now. I think the Pico RP 2350 was product number 6,000, if I'm not mistaken. Or no, maybe it was the Feather. Either way, this is product 3678. So quite a few IDs back, but it's now back. It's got a nice penguin-based silk screen, so really improved silk screen there compared to the old school. Looks really beautiful. If you take a look at some of these pictures right here, you can see on the back there, it lets you know we've got a listing of some different options that you have for the I2S data that you're going to be bringing in. I'm using it in my demo just with the default, but you can flip a couple of options to go with 16-bit, least significant bit, 20-bit, 24-bit. So different message types depending on your usage. Otherwise, there's a mute switch on there. If you want to use that, you can send that pin to high and mute it. And then the rest of it, you'll just take care of in software. So let's see, before I go any further, how about a little demo? So I'm going to switch over to this view here. And one of the reasons I've done that is because you can see that is actually my audio output from the broadcast software. I got to flip a couple things to get stereo from two different microphones working for this demo. So I'm just going to switch to this, and now my voice is just coming through the lavalier mic on my that I've got clipped to my shirt here. That is a second microphone that I have positioned in front of a speaker. So I have a pair of speakers, and what you can see here is I've got a Raspberry Pi Pico. I'm using Synth.io, and I'm going to send 4 notes, sine wave, a saw wave, a triangle wave, and I'm playing them back and forth. So I'm going to be panning them back and forth, which is something we can do in code with a low frequency oscillator. So let me turn up the sound on this, and I'm actually going to take my mic, my lav, and hold it in front of this second speaker. So here we go. Hopefully you were able to hear that. Let me know in the comments actually before I switch my mic back to both channels. Okay, good. You can hear it. Great. So I will explain what I've got going on there while it's still playing. So I'm going to jump over to code view. So this is all running in CircuitPython, and I'm going to turn it down just a bit. Toddbot over in the chat mentioned in stereo headphones, that sounds nice. So you may have 2 speakers in your computer that are close together and you might not hear it as well. If you have some stereo separation or if you wear headphones, you should hear that panning back and forth. So I'm going to turn this down, and I'll leave it a little bit audible while I discuss what's going on in here in code. So you can see, to use this, it's as simple as importing audio bus I/O and then I'm creating the audio object as audio bus IO I2S out, and then I just specify 3 pins. On the Pico, it's 3 consecutive pins, and there are different sets of them that'll work, but I have the bit clock on GP11, the word select on GP12, and the data on GP10. So that's what I have wired up right here. Go a little closer there and refocus that for you so you can see these are the outputs on the I2S stereo decoder, and then those are going to those pins on my Pico. I just have that running through a little proto board there to make it a little easier to wire up. And then power and ground, and that's it. And then my audio is coming out of this jack right here to this little set of amplified speakers. The rest of this encode is me setting up a mixer object that allows me to handle changing the volume if I want to, and then I'm creating a set of waves to work with. I'm setting a few low frequency oscillators. Those are determining the speed at which we're panning left and right. I'm setting up a few notes to play. You can see here they can specify what their waveform is and which of those LFOs they're using. And then in my main loop, I'm just playing and releasing, pressing and releasing those notes in little sets while they wave back and forth. You can hear, if I, what I'll do is I'll actually set the rate a lot faster. Maybe I'll move them all together at the same time. And then I'll move my mic back closer to this one speaker. And then if we want, we can set that a bunch slower. Let's do 0.5, 5, and about 0.25 for that highest note. So it'll really take its time. All right, so I'm going to turn that down, and I'm actually going to fix up my mic audio again so that it is in both ears. There you go. So the reason that I showed that is that while you can send synth IO, you can also play wave files, you can play MP3 files, and you can do it in stereo, right? Everything's going to sound a lot more interesting with some stereo separation in mind. This will work great in all of those use cases. Generating your own audio with something like synth IO, using wave files, using MP3 files. We can do all of those things from the microcontroller or from something like the Raspberry Pi. As Lady Ada mentioned, Raspberry Pi doesn't deal with some I2S decoders very well because it doesn't have the ability to do the clock syncing that we need. This one doesn't require that. This one can take clock sync if you need it, but it will generate those frequencies with a phase-locked loop all on its own to give you the sample, or rather the clock rates that you need. Let's see, rest of this encode, I think, yeah, that's all. That's pretty standard synth IO stuff, but this could be waves, this could be MP3s in playback, just using something like Mixer if you want. It could send different things to different channels, left and right. Really nice to have that in stereo. Squid.jpg over in our Discord mentioned, and now I want to build an MP3 player. Yeah, this would be a really nice DAC to use for that. Most of what you'll do, like volume, you'd probably do in code. This doesn't have like a gain jumper or anything like that. Some amps that are more amplifiers for amplifying to speakers will do that. This one is really just line level out, which is perfect. It's what you can plug anything from headphones, not all headphones, but a lot of headphones that I've tested will work with it, or the line out to line in on an amplifier of some kind, or powered speakers. They're all expecting this level out. Let's see, what else? If we take a look back at this browser here, when I scroll down, we've got, of course, this show embedded in the web page of the product itself. We have some technical details that you can check out, and those will actually take you to the Learn Guide right here. The same pretty much everything applies as before with this re-release. It's just mostly going to be the PCB and silk screen changes that you see. If you click through here, this will show you the pinouts. Excuse me, power pins. You can power this anywhere from 3 to 5 volts. And here's our I2S pins for the data. There's the audio outs. I didn't mention this before, but you don't have to use the jack. The 3.5 millimeter TRS jack is super convenient, but for some setups, you could also use the pads that are built there for the nice isolated and noise-free or mostly noise-free analog ground, and then left and right audio. So you can use those to get your audio out if you don't want to use the TRS jack. These are the optional control pins here. So if you do want to use system clock, there's a thing called video mode that I haven't looked into. I'm not sure what that one's about, but there is a audio mode is the default. Video mode is this, I guess, different clock speed for some setups. There's a mute pin that you can send high to mute the whole system. There's a de-emphasis, which allows you to sort of filter the output a bit. Again, I haven't tested that one. And then there's PLL mode, pulled low for audio, but again, can be changed to do NTSC versus PAL video frequencies, so you don't get noise with video output. And then we have the 2 pins that I mentioned, SF0 and SF1, for adjusting the type of data format. I didn't have to do that in this case. I was just using CircuitPython and the default libraries, and that sends the sort of default I2S message that we're expecting. Info on putting it together and then wiring it up for a Raspberry Pi use case, a Arduino, or CircuitPython. So all of those are possible ways that you can talk to it, and those will all just wire up those 3 pins for the I2S data from the microcontroller back over to the board, and then power and ground. Let's see, what else? I think that may cover it. Let me know if there's any questions over in the chats. Unfortunately, I'm not sure if let me check and see if I can relaunch my YouTube chat. I think it broke. Yeah, sorry, I had a dead YouTube chat window. So hello, Dave Odessa and Tackle the World, ACAT, Tampier, Garrett Taylor. Hello, thanks for jumping in. And yes, you were able to hear those in stereo. Thanks for letting me know that. And I didn't mention before, but yeah, thanks to everyone over in our Discord chat. We got Yanisku7, Toddbot, Squid.jpg. I saw Liz jump by, Some Nice, C. Grover, hello, hello. Hi, Sam J. Ohio. Hey, Paul Cutler. Thank you. Hey, Thin Man. Thanks for stopping by. Let me know if there's any other questions that you have. We do have a few projects that use this. So if you take a look at the Learn Guide, the product page, and scroll down to the bottom, this will usually mention projects that use this. So there's the main Learn Guide. There's also this recent guide that Jepler put out, CircuitPython Audio Effects. He also linked to that, although I think he used a different I2S stereo output for that, because I don't think this was out yet at that time, but he mentions that one in the guide. And then if you look in the Learn Guide, if you do UDA 1334, you'll see there's also an MP3 playback with CircuitPython guide that Jepler put out that also uses this board for I2S output. Let's see. Is that it? Paul asked a question, but then answered himself, so I'll let you check that out if you want over in the guide, or rather over in the Discord. All right, I think that does it. Does that do it? I think that does it. So let's, I'll turn that audio back up and flip my sound again. Hold on 1 second, bear with me. And here we go. Bring that back, okay. So, that right there is my product pick of the week this week. It is the I2S stereo decoder with the UD1334A for Adafruit Industries. I'm John Park, and this has been JP's product pick of the week.